Hey, what's going on, guys? In this video we are going to see an example of Norton's theorem. Norton's theorem is basically when we have a linear circuit like this, we can turn it into a simple Norton circuit with a Norton current source and a Norton resistance, right? And after we turn this one into this, we can connect a load resistance and we can find the current through the load resistance. And now let's go ahead and find our R Norton and I Norton, and let's see how we can do that. R Norton is basically, if you did R Thevenin, it's same approach. We just remove the current source and we make this voltage source equal to 0, and then we find the resistance. And let's go ahead and do that one. Here this is going to be just a straight line. Actually, I just remove this one, remove this current source, so this is going to be appear like this. Okay, then we are going to have this 4 ohm. Then we short circuit this voltage source, so this one doesn't appear. So we are here, we are going to have 4 ohm right here, and then we are going to have this 8 ohm resistance, and then we are going to have this 5 ohm resistance, and also here we are going to have this 8 ohm resistance. Okay, and that's it. And here we are trying to find this R Norton. Okay, so these three are in series, right? So 8 plus 4, 12, 12 plus 8, that's going to be 20. So 20 ohm is going to be in parallel with this 5 ohm. Okay, 5 ohm, and that is R Norton. And now this is in parallel, so we can find the equivalent resistance by simply multiplying them and then dividing by the addition, right? 20 times 500 divided by 25, that's going to be 4 ohm. Therefore the Norton resistance is going to be equal to 4 ohm, right? And now we have found out the Norton resistance. Now the next thing is we have to find the current, Norton current. To find that one, what we do is we connect this one. So when we connect this one, what's going to happen is, if you look at this one, here we have 5 ohm. So when we connect this one, the current doesn't go through this 5 ohm, because it will directly go to this one and it will neglect this part, so this one doesn't even appear, right? So now what we are going to do is we are going to use mesh analysis to find the current across this one, I Norton. And let's go ahead and do the mesh analysis. So let's take this one, this is mesh 1. So here let's say I1 is going through this, and let's take I2 going through this loop, and let's create the equations. I1 definitely 2 ampere, because this is the I1 is the only one passing through this, so I1 is equal to 2 ampere. And I2, we can create equations. This is going from minus to plus, so there's going to be a voltage, so that's going to be a positive value, because that's I1 negative to positive, so that's going to be a positive value, 12 voltage, right? That's voltage rise actually. And when it goes through along the resistance, that's going to be voltage drop, so that's going to be minus 4 I2. But at the same time you can see that I1 is going in the opposite direction of this resistance, so we have to subtract I1 from this one, and it's going to look like this, right? And then this I2 is going through this 8 ohm, so we are going to have minus 8 I2. And then this one doesn't exist, this 5 ohm does not exist, then it goes through this 8 ohm resistance in the bottom, so that's going to be again minus 8 I2, that's equal to 0. Now let's simplify this one. 12 minus 4 I2 plus 4 I1, and 8 that's going to be just 16 I2 is equal to 0. And here we have minus 4 I2 and minus 16 I2, that's going to be minus 20 I2, and this one is I1, right? This is I1. Minus 20 I2, I can move that one to the other side, so that's going to be plus 20 I2. And in this side we have 12 minus 4i1, and we know the i1 is 2 ampere, so we can plug that one right here. So this is going to be 4 times 2. 4 times 2 is 8. 12 minus 8. 12 plus 8. So this is, I'm looking at this one, right? So I'm looking at 4i1 because i2 we moved that one already, so we shouldn't worry about that. I1 is 2 ampere, so 4 times I1, that is plus right here. So 12 plus 8, that's going to be 20. So 20 I2 is equal to 20, therefore I2 is going to be equal to 1 ampere. And this is our current passing through this one I Norton, so this I Norton also equal to 1 ampere, right? Now we have found out the I Norton and R Norton. Now so that we can find the load resist, like current through the load resistance. For example, if we connect a load resistance right here, R load, and here we found out I Norton is 1 ampere, R Norton is 4 ohm. So we've connected the load resistance right here, and the current going through this load resistance, to find that one we have to use this equation, that is I load resistance is equal to I Norton times R Norton over R Norton plus R load. Okay, now let's plug the values. I Norton 1 ampere, R Norton we found out that is 4 ohm, so this is 4 ohm actually. Okay, oh, we put it right here too, so 4 ohm, and in the bottom 4 ohm plus whatever the R load we have, and that's how we find I load, the current through the load resistance. I hope this helps. Thanks for watching.